In 7.2, we focus on the operations of decimals. That's on textbook pages 340 through 356. Remember, the textbook exercise set is completely optional if you ever feel like you need more practice after you do the My Math Lab homework. Before we get started, I want to show you just a couple of resources online that you can use if you begin teaching decimals, even fractions, anything you start teaching, and if you're struggling on how do you explain that to your students. So what I did online is I went to our class website of extra resources. I went here to the middle tab, the curriculum resources, and I clicked on this Region 11 Live Binder. Region 11 is a service center in Texas. We live in Region 17, but Region 11 is really good about sharing their resources. And so this is a website that Region 11 has put together and shared. What it has is it has support for all the different TEKS. And what I like about it is their math specialist has made videos that kind of help you as a teacher find resources and actually go through how you explain the different concepts. So since we're focusing on decimals today, I'm going to click on 5th grade. Here we just have a lot of different activities that have been uploaded that you can click on and use, and you can use this website once you leave my class. You can go to Region 11, you can use the website I've created, but once you click on TEKS support, these are actually little videos that the specialist has created. And so if I click here on multiplying decimals, because we're going to be focusing on operations of decimals today, what it's going to have is it's going to have a video created by this specialist.
Welcome to the 3rd edition of Math Bites.
And it's going to go through just how you can explain it, different resources that you can use, etc. And the thing that I really like about these videos is she attaches everything that she talks about. And so if she uses a worksheet or a website or something that you like, it'll be attached to that video. And it goes through and it explains how you can explain this to your students and so forth. So it's an excellent resource to use. All right, back to our notes. We have operations of decimals, and we're going to talk about just the standard algorithm, but also introducing addition and subtraction of decimals with base 10 blocks. And if you'll recall in the last section, we talked about when we use base 10 blocks, we really have 4 options. We have the cube, the long, the flat, and then the thousands block. And so really we can't use base 10 blocks if we have more than 4 place values represented in our problem. When you have decimals, remember you need to define what those place values are, and like we said, the smallest place value will always be that small little cube. And so on number 1, the smallest place value that I have here is the 100th, and so I'm going to make myself a note that the cube defines the 100th spot. The long then would be describing the 10th place, and then the flat would represent the 1's place. So what I want to do is I'm going to add 2 and 1600ths to 1 and 7300ths using base 10 blocks. So I have 2 1s. Do a better job at that. So I have 2 flats, a decimal point, 1 long, and then I have 6 cubes, that 100th spot. I am adding to that 1 and 7300ths, so I have 7/10ths. So I have 7/10ths and then 300ths. And so now I can use my base 10 blocks to add these numbers together. So when I add up my hundredths, I'm going to add up all of those cubes. I have 6 and 3, so I have 9 hundredths. When I add up my tenths, I have 1 and 7, so if I were to add all of these up, I would get 8 tenths. And then my ones, I have 1, 2, 3. So the summation of those numbers using base 10 blocks is 3 and 89 hundredths. Now let's talk about what that looks like if I subtract those two numbers. So I'm going to redraw this. I have 2 and 1/10. And 6 hundredths. I am subtracting now 1 and I have 7/10. And then my 3 hundredths. Okay, so when I go to subtract, I'm going to mark them out. I'm not adding them together, I'm subtracting. So what I have is I have 6 hundredths, I'm subtracting 3 hundredths. So when I take the 3 away, that's going to cancel out 3, and I'm left with 3 hundredths. On my tenths, it's impossible for me to take 7/10 from 1/10. And that's why in second grade we learned the concept of borrowing. I don't have enough to subtract 7 from it. So what I have to do is I have to borrow a flat. And when I do that, I get 10 longs, 10/10. All right, now I can subtract 1, 2, 3, 4, 5, 6, 7, and what's remaining is 4/10. Now I only have one unit left in the top and the bottom, so when I subtract, they cancel. And I don't have any ones left. My answer is 43 hundredths. So you will come across the concept of the borrowing as well. On the next part, I want us just to add and subtract using the rules for adding and subtracting decimals. And the rule on that is you line up the decimal point. So when I add these, I have 2 and 16 hundredths. I'm adding 1 and 73 hundredths. 6 and 3 is 9, 7 and 1 is 8, 2 and 1 is 3. And so we introduce this addition and subtraction maybe using the base 10 blocks, and then we move forward to the standard algorithm, which is very easy because for adding and subtracting, you simply line up that decimal point. On the subtracting, we have 2 and 16 hundredths minus 1 and 73 hundredths. 6 minus 3 is 3. Once again, we cannot take 7 from 1, so we have to borrow. That's going to make this 1 and this 11. 11 minus 7 would give me 4. 1 minus 1 would be 0. So you see you get the exact same thing as you got above using the standard algorithm. On the bottom of this page, we're going to move from adding and subtracting to multiplying, but we're going to use fractions to model this multiplication. Remember, you can interchange decimals and fractions, and your students should know how to go back and forth. So we're going to use fractions to model how you actually multiply decimals. What we have is we have 3 times 64 hundredths. And so the way that you model this with fractions is you do, this is 3 times 64 hundredths. This 3 is really over 1. It's a whole number. It's a ones place. So it's 3 over 1 times 64 over 100. And as we go ahead, we cannot cross-reduce it all here. So we're going to go ahead and multiply 3 times 64 would be 192. 1 times 100 would be 100. That's an improper fraction. So we know that it's 100 units makes a whole. I have 1 whole and then 92 units left over out of 100. That can be reduced, but we can see that this is a hundredths right here, 92 hundredths. So I know in decimal form, that's 1 and 92 hundredths. So you can model decimal multiplication with your fractions. On number 2, we have 2 hundredths. So that's 2 hundredths times, that's 13 thousandths. So that's 13 out of 1,000. When I go ahead and multiply, that's going to give me 26 out of 100 times 1,000 would be 100,000. And so I have 26 100 thousandths. And so 26 100 thousandths, I have to think about, okay, here's the tenths place, the hundredths place, the thousandths place, the 10 thousandths place, the 100 thousandths place, which I have 26 of. Remember that last digit describes the name of the decimal, so that's going to give me the 26 100 thousandths there, and then I fill in the remainder with zeros. Okay, going on to the second page of your notes, we're going to go ahead and do the multiplication of these fractions using the standard algorithm, the rule that you probably learned. What I like to do is, I like to completely drop the decimals. And so when I look at this, if I have 3 times 64 hundredths, I'm just going to write 64 times 3, because when we multiply, we don't have to line up those decimals. We can actually multiply the digits as if the decimals were never present. So I'm going to do 64 times 3. 3 times 4 would be 12, carry the 1. 3 times 6 is 18, plus 1 is 19. But I have to place that decimal back in. The way that we do that is we go up to the original problem and we look at how many place values there are, or numbers, after the decimal. 3 does not have any numbers after the decimal. The 64, this is 2 place values after the decimal. So what you do is you total up the total place values after the decimal, and that's the number of place values you come in. So when I come in 1, 2, and that makes my answer 1 and 92 hundredths. On number 2, I'm going to multiply 13 times 2. When I do decimal multiplication, I completely drop the decimals because you can. 13 times 2, we should be able to do that in our head, is 26. But I have to think. I have 2 places after the decimal here. I have 3 places after the decimal here. And I add that, and I'm going to come in a total of 5 coming in from the right. So I come 1, 2, 3, 4, 5. There's my decimal point. And I fill in the remaining place values with 0, and I get that same answer that I did on the previous page. On the next problem, we're going to talk about decimal division, but we're going to talk about describing it as far as in base 10 blocks again. So I have 2 7/10, and I want to divide that into groups of 9/10. So basically I need to define what my cubes are going to represent. Here is my smallest place value here. So on this one, a cube is going to represent a 1/10. And then a long for this one is going to represent the ones place. So what I have is I have 2 longs. And then I have 7/10. 1, 2, 3, 4, 5, 6, 7. So that's 2 7/10. And when I divide, that means separate it into groups. So divide it into groups of 9. What I think might be easier is to go ahead and kind of draw the lines in here. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so it shows that long is actually 10 of the 10th place. So when I split that into groups of 9, I have one group of 9/10 here, one group of 9/10 here, and then I have 7 plus this 2 more. This is a third group of 9/10. So when I had the 2 ones and the 7/10, and I split it into groups of 9/10, that's exactly equal to 3 of those groups. All right, now we're going to do division by by the way that we all learned it. We have 21 and 78 hundredths. We're going to divide that into 2 and 2/10. The problem is when you do a division problem, and it says in the directions, rewrite the division problem so there is a whole number divisor. This is a big deal. Your divisor has to be a whole number. And so when I write this, I have the number 21 and 78 hundredths divided by 2 and 2/10. This is the problem. This right here is the divisor, and that cannot contain a decimal. And so what you were probably taught is just to move that decimal over, but what you're really doing, this is a tenth. In order to get rid of that tenth, you're basically multiplying by 10, and if you do that in the bottom, you have to do that in the top as well. So that's going to move this over and move this over as well. And so what we have is we have 217 and 8/10 now divided by 22. What you were probably taught is just to write 21 and 78 hundredths divided by 2 and 2/10. Move this over 1, move that over 1. And that does do the same thing, but you need to think about, what did I actually do to do this? I multiplied by 10 to get rid of that tenth. All right, now we can go ahead and do the division. So 22 doesn't go into 2 or 21. It does go into 217 though, and that would be 9 times, giving us 198. When we subtract, that would be 19. We bring down the 8. When you're dividing with decimals, wherever that decimal is, it moves directly up and stays in the same position. We already know 22 goes into 198 9 times. That's 198 exactly with no remainder. So my answer to this problem is 9 and 9/10. And I'm going to erase to have room to do the next problem. Alrighty, so on this next problem, we have 9 divided by 75 hundredths. Once again, this is my divisor. The divisor cannot contain a decimal. It has a decimal to the hundredths place. Therefore, to get rid of it, we need to multiply this one by 100, which means I would multiply the numerator by 100 as well. What that tells me now is that the problem is 900 divided by 75. So when we do this, the thing is, we don't have to worry about the decimal in the dividend. We have to worry about the decimal in the divisor. And so what that means is the numerator can still have a decimal in it. It's that denominator, that divisor, that has to be a whole number. So when I divide now 900 by 75, that decimal point's here, so it'll move up right here. 75 goes into 90 one time. That's 75. When I subtract, that's 15. I bring down the 0. 75 goes into 150 twice to give me 150 exactly with no remainder. So the answer here is 12. And just keep in mind, your divisor cannot contain a decimal. It has to be a whole number. All right, next thing we talk about is scientific notation. A scientific notation is really a nice way for us to write extremely large or extremely small numbers. By definition, a times 10 to the nth, where a is a digit between 1 and 10, it can be equal to 1, and n is an integer. Scientific notation is standard form. Move the decimal place n times. If n is positive, we move to the right. If n is negative, we move to the left. So we see on number 1 that n is positive, and so based on those rules, we're going to move to the right 7 places. So I'll go ahead and just make a note of that. We're going to the right 7 places. So what I start with is I start with 8 and 4/10. I go 1, 2, 3, 4, 5, 6, 7. And then I fill those in with zeros. And then I'm going to add my commas. So what I end up with is 84 million. And I'm going to actually write that a little nicer. On the second one, my exponent is negative, which means I'll be moving to the left 5 places. So we have 7 65/100ths. We're going 1, 2, 3, 4, 5 places to the left. Fill in with zeros. We have decimal point 1, 2, 3, 4 zeros, and then the 765. So on number 1, we have a very large number represented in scientific notation. On number 2, we have a very small number represented in scientific notation. On the next few problems, we're going to go the other direction. I'm going to give you that large or small number, and I'm going to ask you to write it in scientific notation. You have a 2-step process. You place the decimal in the form where the number is between 1 and 10. You count the number of places the decimal was moved to determine the exponent. And you know our rules already on the positive and negative. So here, if I take this and I bring it in, I'm going to bring it in to where the number is between 1 and 10, which means that decimal point needs to land right here between the 4 and the 2. I'm going to come over 1, 2, 3, 4, 5, 6, 7, 8 places. And when I do that, I have 4 decimal point, 2, 5, 7, times 10 to the 8th because I moved that decimal point over 8 times. On number 2, I have that very small number. I'm going to write that in scientific notation. When I move the decimal, I'm going to place it right here between the 3 and the 1 because that's going to make it 3 and 12/100ths, and that's going to be my number between 1 and 10. So let's count. We go 1, 2, 3, 4, 5, 6 places. So we have 3 and 12/100ths times 10 to the negative 6 because the original number was less than 1. Next part says, write the results of the following in scientific notation. And so we have 4 times 10 to the 5th times 6 times 10 to the 6th. What you can do to multiply these numbers, you can actually make it very easy on yourself. You can multiply the 4 and the 6, and you can multiply the 10 to the 5th times the 10 to the 6th. And that makes this problem much easier. So 4 times 6 would be 24 times 10 to the 11th, because we've done this several times this semester. When you multiply, you add your exponents. Now the problem with this is it's not written in the standard form for scientific notation, because this 24 right here is not a digit or a number between 0 and 10. And so what I need to do is I need to actually move the place value or move the decimal so that it sits right here between the 2 and the 4. What that's going to do is it's going to affect this exponent. So notice I'm actually moving that to the left. When I do that, that's 2 and 4/10. Now it's times 10 to the 12th because that decimal place was moved over. Okay, on the next one, same concept. We're going to take the 18 and divide it by 3. We're going to take the 10 to the 14th and divide it by 10 to the 9th. All right, 18 divided by 3 is 6. When we divide, we subtract our exponent, so this is going to be times 10 to the 5th. This answer is actually fine just how it is, because this number 6 right here is a number between 1 and 10, so we don't have to do that adjustment like we did on number 1. Last thing for this lesson is some rounding. And so when we do rounding as far as decimals, it's very similar to rounding we do with whole numbers. We locate the place value that we're rounding to. We underline this digit. We look to the right. If it's 5 or greater, we round up. If it's 4 or less, we keep it the same. Now, step 3, all digits to the right of the underline become 0. And if there are no digits to the right of the decimal, those places do not need to be written. So in this one, we're rounding to the nearest 10. Here is the tens place, and so I look to the place value right beside it on the right side. That is a 0, so it's definitely 4 or less, and so rounding to the nearest 10, this is going to be approximately 40. To the nearest 1, here is the ones place. The number to the right of that is 8, so that's definitely greater than 5. So I'm going to round it up. So this would be approximately 41 rounded to the nearest 1. To the nearest 10th, I'm going to look at the hundredths place to the right of it, which is greater than 5. So that's going to make this round to 40 and 9/10 approximately. And then to the nearest hundredth, here is the nearest hundredth. To the right of it, I have a 9, and so that's definitely greater than 5. But when you round that up, what it actually becomes is approximately 40 and 90 hundredths, because the 89, when you round it up, will round up to 90. So you should be well equipped now to do your homework in My Math Lab.